Question 6, differentiation from first principles. Can you believe it? What's that? F of x plus h, 2 by x plus h to be squared, plus 4 times x plus h. What do I always tell you to do at the start? Write down your answer. It's going to be 4x plus 4. This will help us along our travels. So this is equal to 2 times x squared plus 2xh plus h squared plus 4x plus 4h. You were warned this was coming up. So this is 2x squared plus 4xh plus 2h squared plus 4x plus 4h. Just patience required. This is f of x plus h. So what do we want to do? Well, we want to get to our answers, so we want to take away a few of these guys. What's minus f of x? We're going to take it away. I'm just looking at the change in slopes here, but we don't need to worry about too much of that when we've learned this off. Minus 2x squared minus 4x. That's a different lesson to understand this. So this is going to give us 4xh. I'm going to bring the 4h beside it and put the 2h squared at the end. Why are all these h's here? In f of x plus h minus f of x. Don't take any shortcuts here because we need to divide by h now. So I'm going to write it again. F of x plus h minus f of x all divided by h is equal to 4x plus 4. There's your answer appearing. Plus 2h. What do we want to do with the 2h? We want the limit as h, as h tends to 0 of the whole expression f of x plus h minus f of x all over h is equal to 4x plus 4. You're an expert at these at this point. Hopefully the rest of this question didn't challenge you too much. Part B, we have a rectangle is expanding in area. I'm going to draw a rectangle straight away. A rectangle is expanding in area. Its width is x. Let's call this its width. And its length is always 4 times its width. 4x. I don't think it matters which one they are. So find the rate of change of the area with respect to x. Area is equal to 4x squared. The rate of change of the area with respect to x is the 80x. So that's equal to 8x. What else are we told? When the area of the rectangle is 225. So we can say 4x squared equals 225. So x squared is equal to 225 over 4. So x is equal to the square root of the top and the bottom, which will be 15 over 2, which is 7.5. When the area is that, the rate of change is going to be 8 times 7.5, 56 and 4, 60 centimeters squared is the rate of change of the area for part B. In part C, we're given the graph of this cubic function in the domain between 0 and 4. The max value of p prime x, we're asked to draw a graph. I haven't got it on this slide, but you're asked to draw the graph of the derivative. The max value of the derivative is 1, and p prime 0 is minus 3, so it's going to cross the y-axis at minus 3. We'll see this in a sec. And up here at 1, the max value, and p prime x is the derivative we're told at. Now what we need to know about cubics and quadratics, or the derivatives, the roots of the quadratic will be wherever these max values are. It's going to go through here like this. So it's going to go down, and it's going to, well, it's going to come through the y-axis at minus 3, so it's going to be a negative one here. P, if it's to go through 1 and 3, it's going to come up like this and down like this. This is just a sketch. Let's see what graph they gave us with these values of our roots at 1 and 3, or around 1 and 3, and crossing the y-axis at minus 3 and the max value at 1. So this is what they gave us. So they said p prime 0 is equal to minus 3. That's our minus 3 in. Looked like they crossed around 1 and 3. I'm just going to do big dots. The max value was 1 up here. I'm going to put it at the midpoint of those roots approximately. So the graph of this is going to come up and around and back down like this approximately. And if you're not an expert on these graphs, go to GeoGebra. Here's a cubic in blue here. You can see the max points in relation to the roots of the quadratic below. Max and min in relation to the roots of the quadratic. It's just a nice image to show you what happens, where they go. So hopefully you've done well on the short questions.